My passion is tennis, but because many of the tennis videos I found on YouTube videotape matches from behind players, it was hard to track the ball to get a good analysis of its height during its travel. For this reason, I chose to do this lab on table tennis. First, I analyzed the movement of a no-spin table tennis serve. The mass of the table tennis ball is 0.0027 kilograms, and the initial position of the ball was negative 0.332 meters in the x direction and 0.265 meters in the y direction. I set up my axes and tracked the movement of the ball. I found the initial velocity of the ball to be 1.647 meters per second in the x direction and negative 0.3235 meters per second in the y direction. I ran the code and graphed my video data against my computer model using only gravity as the net force. As you can see, using only gravity was a pretty bad model. Assuming air resistance had something to do with it, I rewrote my code to account for that. Using a drag coefficient of about 40, I got the video data and the model to match up pretty well. But having no spin on the ball isn't usually what tennis players aim for. In browsing YouTube, I found that the same goes for table tennis. Backspin and topspin are both techniques used by players to get the ball to do some pretty cool stuff. Tracking a serve with backspin, I found the initial position of the ball to be negative 0.319 meters in the x direction and 0.132 meters in the y direction, and the initial velocity of the ball to be 1.909 meters per second in the x direction and 0.03 meters per second in the y direction. I plugged these initial conditions into my code for air resistance and plotted the video data and the computer model on the same scatter plot. As you can see, the actual ball went higher and fell faster than the computer model. This can be explained through angular momentum and something called the Magnus effect. The Magnus force is due to friction between the air and the object's surface. It is a lift force that is perpendicular to the direction of movement, and it can lead to a longer hang time. Britannica explained it as a spinning object moving through a fluid departs from its straight path because of the pressure differences that develop in the fluid as a result of velocity changes induced by the spinning body.